Today, we are going to focus on three core goals that are vital for managing successful software development project. First, we will discuss how to select an appropriate branching strategy of your product or organization. Branching strategies are essential because they help manage different development paths such as bug fixes, new features, and production-ready code. Without a clear strategy, you could end up with a messy code repositories, difficult merges, and conflicting changes. The second goal is to maintain a healthy commit history. A clean commit history ensures that every change to the code is traceable and it's easy to understand the context behind modification. A messy commit history can slow down the debugging process and make it harder to pinpoint where things went wrong. The third goal is to improve quality and save time through code reviews. Code reviews are critical practice for catching bugs early, improving code quality, and ensuring that best practices are followed consistently. Code reviews not only help in maintain high quality code but also foster collaboration and knowledge share among the team. Now, it's important to discuss about that what is commit. In a Git, a commit represents an atomic change to the code base. This means that a commit is a single indivisible unit of change. Each commit can affect one or more files, but it is considered one logical change. This concept is important because it allows you to break down complex changes into smaller, manageable steps, making it easier to track the history of the project and troubleshoot issues. Every commit has metadata associated with it, which includes the author's name, the timestamp of when the commit was made, and a commit message that briefly describes the change. The commit message is an essential part of the process because it helps collaborators understand the intent and the context of the change. Git also differentiates between the author and the committer. The author is the person who originally created the change, while the committer is the person who applies the change onto the repository. This distinction can be important in cases where some contributor contributes to a project while someone else applies the changes. Every commit has a parent commit, which shows the state of the repository before the change. It also has a child commit that represents the state of the repository after the change. When conflict arises, merge commits are created. A merge commit has two parents, which represents the two different branches being merged together. This system of parent and child commits along with the merge commits allow us to maintain a detailed and traceable history of the project, making it easier to understand how and when the project evolved. Now let's discuss about the commit message style. Writing good commit messages is a fundamental practice for maintaining a cleanable, understandable Git history. A commit message typically has two parts, the subject and the body. The subject should be concise, ideally no more than 50 characters, and it should describe the change clearly and specifically. For example, instead of using a vague subject like fixed bug, a more descriptive message should be fixed index out of the range error in user login function. This gives any collaborator reading the commit history an immediate understanding of the change. After the subject, the body of the message comes next. The body should be used to explain why the change was made, providing the necessary context and clarify any important details that might not obvious from the code itself. The body should have wrapped at least of 72 characters for readability and it can also include references to any related issues or tickets in your project management system. By including references to tickets, you link the code changes directly to the context of the problem they are addressing. For example, you might write something like fixes #123, where your user profile data was not loading correctly. This creates a clear connection between the code and the issue it resolves. Consistent and clear commit messages are essential not only for your team's productivity, but also for anyone who may need to work on the project in the future. By adhering to a proper format, you make the history of your project easier to follow and manage. Branch management is a crucial part of any Git workflow. There are several types of branches that you will encounter and each serves a specific purpose in the development process. The trunk master or the main branch is a primary branch that represents the stable production-ready code. This branch should always be in a buildable state, meaning that it should always be able to deploy it or release without any issues. This is the branch that end users or clients will see, so it's important to ensure that it always free from unfinished work or unstable features. The development branch is where the most of the iterative work happens. This branch is typically used for long-term ongoing features that will eventually be merged into the main branch once they are completed and tested. A good practice is to merge the development branch into trunk frequently. This helps to avoid huge conflicts that may arise when merging after a long period of time. Frequent merges allows you to catch issues early and ensure that your changes align with the current state of the main branch. After that, the release branch is used to manage the version of the software that is deployed or about to released. The branch is used for bug fixes, security patches, and the final adjustments before releasing the software to the public. It allows the team to continue working on a new feature in the development branch while maintaining stability in the release version. The use of these different branches ensured that work on a new feature doesn't disrupt the stable, production-ready code and help keep the development process organized and manageable. After the branch management, we are discuss about some merge strategies. When working with multiple branches, one of the most important decisions that we will need to make is how to merge them back together. These merge strategies you choose significantly impact the history of your project. First, there is a linear history. Linear history is basically a strategy that involves rebasing your feature branch into a latest version of the main branch, ensuring that all the commits follow a single straight line. This approach avoids merge commits and makes the history cleaner and easier to follow. However, it requires resolving conflict during the rebase and it can be difficult to manage in large complex projects with multiple contributors. The one-way merging strategy involves creating a merge commit that combines the changes from two branches. In this approach, the merge commits records the merging of the branches and ensures the commit history reflects the correct order of the changes. The downside is that merge commits can clutter in the history if they happen too often. Finally, two-way merging involves merging changes from the trunk into feature branch before merging it back into the main branch. This helps resolve conflicts early and ensures that a feature branch management are up to date with the latest changes in the main branch. Two-way merging can be helpful for long-running feature branches, but it requires frequent attention to avoid conflicts from building up over time. Each merge strategy has its pros and cons, and the key is to choose the right one based on your project's needs, according to your project's needs and the team workflows. Code reviews are one of the most effective ways to improve the quality of the code you write. By having another set of eyes on your code, you can detect defects and bugs early in the development process, which can have a significant amount of time in the long run. In addition to finding bugs, code reviews also improve the quality of the code by ensuring that it follows best practices and is readable and maintainable. Code reviews also provide an opportunity for collaboration. When reviewing someone else's course, you can share your knowledge, point out potential improvements, and learn from the way others approach coding problems. This not only improves your quality of your project, but it also enhances the skills of everyone on the team. Code reviews are a form of knowledge sharing, allowing more experienced developers to mentor junior team members and helping everyone stay on the same page about the project's goal. Beyond just improving quality, code reviews also include the traceability and accountability. When every change goes through the review process, it's easy to see why certain decisions were made and who was involved in the process. The traceability is invaluable when troubleshooting issues or trying to understand the rationale behind a specific change. It also helps hold team members accountable for quality of their work, ensuring that everyone contributes to maintaining the project standard. To make the code review process as effective as possible, it's important that the code you submit is reviewable. This means making sure that your changes are small, logical, and self-contained. Large, complex changes that make multiple of modifications can make the review process difficult and time-consuming. Keep changing small allows the reviewers to focus on issues at a time, making it easier to understand and validate the changes. It's also important to focus on correctness during code reviews. Check that the code works as expected, handles its glitches, and adheres to the requirements outlined in the task or ticket. You should also evaluate the context in which the changes are made. For example, how will the change affect other part of the system? Are there any potential side effects that could cause issues later on? Finally, using a checklist during code reviews can help ensure that no important areas are overlooked. A checklist might include questions like, does the code follow the project convention? Are these adequate tests? Is the code easy to understand? By making the code review systematic and consistent, you can improve the quality of your project while making the review process more efficient. Let's walk through an example of a typical bug fix workflow. First, we will need to create an issue that clearly describes the problem we are trying to fix. A well-written issue should provide enough context so that anyone working on it understands the scope of the problem. Once the issue is created, we can begin working on the fix. Start by writing and testing the code, and it's important to write tests for the bug fix, ensuring that the problem is resolved and the fix doesn't break anything else in the system. After writing the code and running the test, we will open a pull request. The pull request should include a clear description of the changes made, the rationale behind them, and any relevant test results. This is your chance to communicate with your team and get feedback. Once the pull request is open, your teammates will review it and provide feedback. It's important to address this feedback by making necessary changes or clarification. Once the code has been reviewed and approved, we can merge the change into an appropriate branch, usually the development or main branch, depending on your workflow. This process ensures that the bug fix has been properly reviewed and integrated into your project.